In this question, we want to find the number of ways to place people. In here, we are given 2D plane where some coordinates are given. Now, we need to find a pair such that they are forming a rectangle. For example, this is forming a rectangle. This one is also forming a rectangle. So, also there is one more condition, that suppose if we have one point here, we don't want to consider this one as a rectangle because here this point is coming under this rectangle, this point is coming under this rectangle, and this one is also coming under this rectangle. So basically no other points can come into this rectangle. This is what the two conditions are, that they need to form a rectangle and no other points can come into this rectangle. Brute force approach is that we will go through all the points, right? We will go through all the points, we will match them with the other points and find out whether they are forming a rectangle or not. So in order to find out whether they are forming a rectangle or not, we just need 2 points, and here we will check that the x1 is always lesser than x2 and the y1 is greater than y2. So using this formula, we will be able to find out whether 2 points are forming rectangle or not, and whether another point is coming under that or not. We will run another loop, and in that we will find out whether any other point is coming under this rectangle or not, being intersected or not. Basically we will check that if we consider this as the x3 y3, so x3 should not be greater than or equal to x1 and lesser than or equal to x2. Same thing for y3 should not be lesser than or equal to y1 or greater than or equal to y2. This is the brute force solution, and total time complexity it will take is n to the power cube 3, because there will be 3 loops, one for the two loops for to compare whether they are forming rectangle or not, and one to check whether any point is coming under them or not. Now what is the other way, more optimized way we can use? So other way to find out whether how many pairs are there forming a rectangle or not is that, what if we go into these points line by line in sorted order? So we want to go into these points increased by x, increasing form by x, decreasing by y. So that means in this order, first we will visit this point, then this one, then this one, then this one, and then this one. So there is a benefit of doing this, and we will think about it, that what is the benefit of doing this. So see, this is the first point, right? So we will start for this point. If you see, for this point, what is the area, what is the dedicated area in which if we place any point, it definitely will make a rectangle. So the dedicated area for this point we can consider is this area, right? This is the area. If we place any random point, it will make a rectangle. So we will take 2 points, valid upper bound, or for simple terms I will take upper bound and lower bound. So for this one this is the upper bound, and lower bound we can take anyone because it can go until, let's say, integer minimum value, or we can say minus infinite. So this is the lower bound. Okay, so basically this whole area is considered to be a valid rectangle that can form along using this point. Okay, so now we will go to, now this is our starting point, right? This is starting point. Now we will go to the next points because we have already sorted them, right? In also it will go into this order only. The next point will be this one. So when we will reach this point, when we will compare it with this point, we will check is this is coming under the valid bounds, right? The bounds that we have considered, is it coming under this? Yes, it is coming under this. So we will consider this as the valid rectangle, because since we are going into the sorted order, right? So it is always going to be making a rectangle, because it is always going to be the top or either left side, or it is going to be the on the right or bottom side. So it is always going to be making a rectangle because of the sorting. Now since we just want to find out whether it is a valid rectangle or not. Valid means there are no points coming under this. And since this is the first one, and this to check that this is first one, and also this is coming under a condition, so this is a making a valid rectangle. So our result so far will be 1. Now after this we need to decrease the our bounds, because why, right? Because see, if we don't do that, right, all these will be considered as the valid rectangle, and we don't want that. Suppose this is also coming under the valid bounds, but these are all coming under these rectangle, right? So this is not a correct way, right? So we have to shorten our bounds. And now to which range we are going to shorten it. So what we are going to do is, we will check that what is the lowest, what is the value we can set for lower bound, because upper bound is always going to be this. We just need to adjust the lower bound. So lower bound now will go to this place. Why? Because if any point after taking this point, let's say we have another point here. Okay, now is this will this make a valid rectangle? No, right? Because this one we have already considered, and this is now coming under this. So whatever point we are going to take that is coming, that is located after this bound, lower bound, will be invalid. So we have to shorten this bound. So the next boundary will be this one. Okay, so the next boundary will shorten to this one, and this is our lower boundary. Fine. So now we have shortened our lower boundary. We will go to the next point, which is this one. Okay, this one rectangle, let me mark this. Now this is the next point we are going to consider. We will check, is this coming under the boundary? Yes, it is. So we will say now result will become 2. Okay, now again we will have to short the lower boundary for the same reason, right? Because whatever that whatever comes after this will not be marked as valid, will not be considered as valid. So same thing we are going to do for this lower boundary. So lower boundary will be shortened to this range. Now next point is, as per the sorting, will be this one. Now if you see here, this is also a valid rectangle as per the document, as per the question. This is also considered as a valid rectangle. So same thing will happen, our result will be counted to 3 and the lower bound will again decrease to this one. And now since the lower bound and upper bound became same level, right, came into same level, so this we will break a loop for this starting point. Whatever non-intersecting rectangles can be found, we have found all of them. So 3 will be the answer for this one. Okay, same thing. Now the loop, same thing will repeat for this one. The boundary for this one will reset to this, right, which is minus infinity. And now this is also again forming a rectangle, so this will be considered as a rectangle. But since after doing this, lower bound and upper bound will have the same values, we will break our loop. Now we will go to next point, and for next point, this point the boundary will be this whole one, and then this, when we want to find out, compare it with this point, this is coming under correct condition, so this will be considered as correct point, and this will create a valid rectangle for starting from this point. But when we will go to this point, right, for along with this point, when we will go to this point, this is not coming under our boundary, so this won't be considered as the rectangle, this also won't be considered as the rectangle. And let me show you the code that I have written for this one. So in the code as well, what we are doing is, we are first sorting the points increasing by x and decreasing by y. Then we are taking this at the starting point. Then we, for the every starting point, we have considered valid lowest y and valid upper y. Why we have not taken the valid x or x, right? Why we have not considered the boundaries for x? Because since we are going into the sorted order, right, so x, the previous at the start, for the starting point, x is always going to be lesser, so that is always going to be valid. That's why we have not taken the x. We just need to find out about the y. That all could happen, all could be possible because of the sorting. Now we are comparing it with all other points starting from the starting point till the end. Now we are checking if these are, if the y1 point, that means the point 2 that we have considered, is coming under the boundary. We are increasing the count, right? We are resetting the lowest point to whatever we have found so far, and then if we are reaching the upper boundary, we can either write it down valid lowest y as well. Here I used y1. Here the condition could be valid lowest y is equal to valid upper y. In that case, we are just breaking the current loop, right, this loop, and then we are restarting it for the other rectangles. So this is all. At last we send the count.